High above the Earth, far beyond the clouds, there is a place where sound does not exist. No wind can be heard, no birds fly here, no engines roar, only silence. At almost 39 kilometers above Earth, a single human stands at the edge of space. Below him is the blue planet, above him is the dark universe. From here, Earth looks fragile, thin, like a living world protected by a very weak layer of air. This is not a normal height. Commercial airplanes fly at around 10 kilometers. Mount Everest stands at 8.8 kilometers. But here the air is nearly gone. Breathing without protection is impossible. Life should not exist, yet one man is here. Inside a small capsule floating under a giant balloon, he prepares to do something no human has ever done before. He is not an astronaut. He is not inside a spacecraft. There is no rocket engine to protect him. He is alone. The suit he wears is the only thing between life and death. Outside the capsule, the sky is no longer blue. It is dark blue, slowly turning black. Stars are starting to appear even though it is daytime on Earth. This is the edge of space. Inside the helmet, his breathing is slow but heavy. Every breath matters, every movement is careful. His heart beats loudly in his ears. Below him, the Earth curves gently. Oceans, clouds, and land look peaceful. But this peace hides danger, because one step forward will change everything. A place humans were never meant to be. Humans evolved at sea level. Oxygen-rich air, stable pressure, comfortable temperatures, but at this height, the environment is hostile. The air pressure is so low that human blood can begin to boil. Temperatures drop below -60 degrees Celsius. There is no oxygen to breathe. If the suit fails for even a few seconds, survival is impossible. There will be no pain, no time to react, just darkness. This is why no human stands here by accident. This moment took years of planning, thousands of tests, hundreds of scientists and engineers. Every screw, every wire, every layer of fabric was checked again and again, because here mistakes cannot be fixed. Mission Control is watching far below on Earth. Inside a control room, dozens of experts watch their screens, heart rate monitors, oxygen levels, suit pressure readings. Every number matters. Silence fills the room. They know what is about to happen. They know that history is seconds away, but they also know the risk. No human has ever broken the sound barrier using only their body. No human has ever jumped from this height. There are too many unknowns. What if he spins uncontrollably? What if the suit fails? What if his body cannot handle the speed? There is no rescue mission. Once he jumps, he is on his own. The weight of the moment. Back at the capsule, the man opens the door. Cold air rushes out. The darkness of near space stares back at him. He steps outside. Now he is standing on a small platform high above the world. There is no sound of wind, no feeling of falling yet, just silence. He looks down. Earth feels unreal from here. Cities are invisible. People are invisible. From this height, humanity feels very small. This jump is not about fame. It is not about records. It is about pushing the limits of human survival. Why this jump matters. For decades, scientists have asked an important question. What happens if an astronaut needs to escape from space? What if something goes wrong at extreme height? Could a human survive a fall from near space? The answer could change how future space missions are designed. This jump is a test, a real test, with a real human life. The data collected today will help improve spacesuits, improve astronaut safety, save lives in future missions. This is not entertainment. This is science at its most dangerous level. Time slows down inside the helmet. Time feels different. Seconds feel like minutes. Thought become louder. He checks his position. He checks his posture. He listens to Mission Control one last time. Everything looks good. These words sound calm, but everyone knows the truth. Nothing about this is safe. One step into the unknown, he moves closer to the edge. Below him is a drop so high that the human brain cannot fully understand it. There is no ground visible, only layers of atmosphere. First thin air, then thicker air, then clouds, then Earth. Gravity waits patiently. Once he leaves the platform, gravity will take control. There will be no turning back. The fear no one talks about. Fear is natural. Even trained professionals feel it. At this height, fear is not panic, it is awareness. Fear reminds him to stay calm, to follow training, to trust the suit. His breathing becomes steady. This is the moment he trained for. The final pause. For a few seconds, everything stops. The universe feels still. The balloon holds the capsule silently. The Earth rotates below. The sun shines brightly. Millions of people continue their lives without knowing what is happening above them. They do not know that a human is about to fall from the edge of space. They do not know that physics is about to be challenged. History is about to begin. Mission Control gives the final confirmation. All systems are green. The world holds its breath. He takes one final look at Earth. This is the last moment of stillness. Then he steps forward and disappears into the silence. The moment the man disappeared from the platform, the story did not begin in the sky. It began many years earlier. Long before the capsule, long before the suit, long before the jump. This story begins with a question that haunted scientists for decades. Can the human body survive near space? The problem with space is beautiful, but it is unforgiving. There is no air, no pressure, no warmth. Humans do not belong there. Every astronaut who travels beyond Earth carries life with them in machines, spacecraft, space suits, life support systems. But machines can fail. History has shown this again and again. Small problems in space can become deadly in seconds. Scientists knew something important was missing. They understood rockets, they understood orbit, but they did not fully understand the human body in extreme conditions between Earth and space. This region was a mystery. The dangerous zone between Earth and space, between the ground and outer space, lies a silent killer, the upper atmosphere. Here, the air becomes thinner with every kilometer. Pressure drops rapidly. Oxygen disappears. At a certain height, the human body reacts in strange ways. Blood behaves differently. Muscles lose control. The brain struggles to stay conscious. This zone is too high for airplanes, too low for satellites, and almost impossible for humans. Scientists called it near space, and they needed answers. What if an astronaut must escape? One question worried space agencies the most. What happens if an astronaut must escape a spacecraft at extreme height? During launch, during ascent, during an emergency, a spacecraft failure at high altitude leaves no room for rescue. Parachutes may not open properly. Ejection systems may not work. The human body may not survive the fall. Without real data, engineers were guessing. Guessing in space is dangerous. Old experiments, new limits in the past. Military pilots had reached high altitudes. Some had ejected from aircraft, some survived, some did not, but those jumps happened much lower. None reached the edge of space. Technology had improved, materials were stronger, suits were better. Now science was ready to push further, but this time there would be no aircraft, no engine, just a human body and gravity. Choosing a human test subject, this mission needed more than technology. It needed courage. Person chosen had to trust science completely. They had to remain calm under extreme stress. They had to accept the possibility of death. Training alone was not enough. The mind had to be strong. Every movement during the fall had to be controlled. Every reaction had to be calculated. This was not a stunt. This was a scientific experiment using a human body. Years of preparation before the jump. There were years of preparation. Endless simulations. High-altitude tests. Pressure chambers. The human body was pushed to its limits. Low oxygen tests. Extreme temperatures. High-speed airflow. The goal was simple. Find out how much a human can endure. Every test added a piece to the puzzle, but simulations are never perfect. Real conditions are always different. That is why the jump had to happen. The suit was the real hero. The spacesuit was not just clothing. It was a personal spacecraft. Inside the suit, oxygen was carefully controlled, pressure was balanced, temperature was regulated. The suit had to remain stable at supersonic speed. If pressure dropped suddenly, the body would fail instantly. If temperature control stopped, freezing would begin. The suit carried human life through near space. It was tested again and again. Still, uncertainty remained. Fear in the control room as the man fell silently from the edge of space. The control room was tense. Every sensor was active. Speed readings climbed rapidly. Heart rate increased. Body temperature changed. Scientists were seeing data never recorded before. This was history being written in numbers. No one spoke because everyone understood one thing: this experiment could not be repeated easily. There was only one chance. Gravity takes control. As the man continued falling, gravity became stronger. Without air resistance, speed increased fast. Faster than airplanes, faster than sound. But the human body was not designed for this. The risk was not just speed, it was stability. At extreme velocity, even a small movement could cause spinning. Spinning could cause unconsciousness. Unconsciousness could mean death. The margin for survival was thin. Why this jump was different? This jump was not about breaking records. It was about understanding limits. Scientists wanted to know, how fast can a human fall safely? Can the body remain stable at supersonic speed? Can consciousness be maintained? The answers would shape future missions, from Earth to orbit, from orbit to deep space. The human body vs. physics. Physics does not care about courage. Gravity pulls everything equally. The human body is fragile in comparison. Bones, blood, nerves, all vulnerable. At extreme speed, even air molecules become dangerous. They hit the body like invisible bullets. The suit had to protect against this invisible force. This jump was a battle between biology and physics. Moments of uncertainty as the fall continued. Data streams showed something unexpected. The body began to rotate, not fast, but enough to worry scientists. Small rotations can become violent spins. The control room prepared for the worst. If spinning increased, survival chances would drop sharply. There was nothing they could do. The man had to fix it himself. Trusting training inside the suit, training took over. Body position adjusted. Arms moved slightly. Legs stabilized, small movements, precise movements. This was the difference between control and chaos. Slowly, rotation reduced. Data stabilized. The control room breathed again. Why this moment changed everything? This was proof. Humans could survive freefall from near space. They could remain conscious. They could remain stable. They could break the sound barrier. This moment changed how scientists viewed human limits. It opened new possibilities, new designs, new safety systems, new missions. A message for the future. This jump was not just about today. It was about tomorrow, about future astronauts, future explorers, future missions beyond Earth. The data collected would save lives, not in theory, in reality. The fall continues as the man fell deeper into Earth's atmosphere. Air resistance increased. Speed began to slow, but the danger was not over. Heat, pressure changes, oxygen levels, every second still mattered. The man continues to fall, but to understand what is happening to his body, we must stop for a moment, because this place he jumped from is not Earth, and it is not space either. It is something in between, a region humans rarely see, a region science still struggles to fully understand. This place is called the edge of space. Where does space actually begin? Many people believe space begins suddenly, like crossing a line, but in reality there is no clear border. Earth's atmosphere slowly fades away. The higher you go, air becomes thinner, pressure drops, oxygen disappears at around 100 kilometers. Scientists call it space. But long before that, humans can no longer survive. At 39 kilometers, where the jump began, the atmosphere is almost gone. This is the danger zone. Why the sky turns black on Earth? The sky is blue because air scatters sunlight. But at extreme height, there is not enough air. Light is no longer scattered. That is why the sky turns dark. That is why stars appear in daylight. From the edge of space, Earth looks protected by a thin blue layer. That thin layer is everything. It holds air. It holds life. It holds humanity. The silent killer, low pressure, is something humans never think about, but it keeps us alive. At sea level, pressure pushes air into our lungs. It keeps blood stable inside the body. At extreme altitude, pressure drops dangerously low. If pressure outside the body is too low, blood can form bubbles, oxygen escapes from tissues, consciousness fades quickly. This condition is deadly. Without protection, survival time is seconds. This is why the suit is critical. The suit vs. the vacuum. The suit around the man acts like a personal atmosphere. Inside it, pressure is maintained, oxygen is supplied, body fluids are protected, but the suit must do more. It must remain stable while falling faster than sound. At supersonic speed, air becomes aggressive. Even thin air pushes hard against the body. Any weakness in the suit could be fatal. Temperature at the edge of space, near space, is extremely cold. Temperatures drop below -60 degrees C, but cold is not the only problem. As the man falls, temperature changes rapidly. Cold at the top. Heat builds as air thickens. This rapid change can damage equipment and the human body. The suit must adjust instantly. Failure is not an option. The human brain at extreme altitude, the brain depends on oxygen. At high altitude, oxygen levels drop. Even with oxygen supply, the brain reacts differently. Vision can blur, judgment can weaken, reaction time slows. That is why training is critical. The man must rely on muscle memory. Thinking too much can be dangerous. Falling without feeling the fall. In the first moments after the jump, something strange happens. The man does not feel like he is falling. There is no wind, no resistance, no sensation of speed. It feels like floating. This is because air is too thin to push against the body. Gravity accelerates him silently. Speed increases rapidly, but the body feels nothing. This illusion is dangerous. Speed beyond human experience. As seconds pass, the man becomes faster than any human before him. Faster than commercial jets, faster than military aircraft. He approaches the speed of sound, but there is no sonic boom. Sound needs air, and here air is almost absent. This is why breaking the sound barrier is silent. Physics behaves differently at the edge of space. The risk of losing control at extreme speed, stability becomes everything. If the body tilts slightly, air pressure becomes uneven, rotation begins, spin can increase rapidly. This is called a flat spin. Flat spin is one of the greatest dangers. It can cause blood to rush away from the brain, loss of vision, unconsciousness. If unconscious, the body cannot correct itself. That is why body position matters. Training for the impossible. Before this jump, the man trained for years. Wind tunnels, simulated free falls, high-speed airflow tests. Every movement was practiced. Arms slightly out, body aligned, head stable. Small movements create big effects at high speed. This training is now being tested. Data no one has seen before. As the man falls, sensors collect data, speed, pressure, temperature, heart rate. This data has never been recorded before. Computers process numbers in real time. Scientists watch closely. This data will change space science, not in books, in real missions. Why near space is so dangerous? Near space is more dangerous than outer space in some ways. In space, there is no air. Conditions are stable. In near space, air density changes rapidly, forces are unpredictable. This makes control difficult. This is why aircraft cannot fly here. This is why this jump is so important. The invisible wall of air. As the man continues falling, something begins to change. Air density increases slowly. At first, it is barely noticeable. Then resistance builds. The body begins to feel pressure. Wind noise slowly returns. This is where danger increases again. Transition zones are always risky. The body begins to feel gravity now. The fall feels real. The body senses acceleration. Wind presses against the suit. Temperature rises slightly. The man is now moving through layers of atmosphere. Each layer behaves differently. This is where control is tested the most. Science watching in silence in mission control. No one celebrates, not yet. They know that survival is not guaranteed. The most complex part of the fall is happening now. Transition from near vacuum to thicker air. Mistakes happen here. Why this knowledge matters. Understanding the edge of space helps humanity prepare for the future. For space tourism, for emergency spacecraft escapes, for deep space missions. This knowledge cannot come from simulations alone. It must come from reality, from real human experience. The fall continues. The man continues falling toward Earth. The atmosphere thickens. Speed begins to change. New dangers appear. Heat, pressure, violent air forces. The calm silence of near space is gone. The most intense phase is approaching. Before the jump, before the fall, before gravity took control, there was technology. Without it, this mission would be impossible. At the edge of space, technology is not support. It is survival. Every breath, every heartbeat, every second of life, all depended on machines built by humans on Earth. The capsule that reached the edge of space, the journey did not begin with falling. It began with rising. For more than 2 hours, the capsule slowly climbed into the sky. Not with fire, not with engines, but with a giant helium balloon. Silent, gentle, deceptive. As the balloon rose, the air around it became thinner. The balloon expanded. At low altitude, it was small. Near space, it became massive. The capsule below it looked tiny, fragile, yet inside it, a human life was protected. Inside the capsule was not large. There was no room to walk, no comfort. Inside were oxygen systems, pressure controls, communication equipment, emergency backups. Everything was designed to be simple, because simplicity reduces failure. The capsule had one job: carry a human safely to the edge of space, and then let him go. A silent ride upward. As the capsule climbed higher, the world below changed. Clouds became thin layers, mountains flattened, the sky darkened. There was no vibration, no engine noise, just slow movement upward. This silence gave time to think, too much time. That is why the man focused on procedures, checklists, breathing, posture. The mind must stay calm. Why rockets were not used? Many people ask a simple question: why not use a rocket? The answer is risk. Rockets bring extreme forces, vibrations, explosions. This mission required control. The balloon allowed a slow, stable ascent, no sudden acceleration, no shock to the body. This made data more reliable and survival more likely. The suit, a personal spacecraft. The suit was the most important part of the mission, more important than the capsule, because once the jump began, the suit was everything. It was not clothing. It was a spacecraft shaped like a human body. What the suit had to do: the suit had to solve many problems at once. It had to provide oxygen, maintain pressure, control temperature, protect against extreme speed, prevent body fluids from boiling. Each problem alone is difficult. Together, they are deadly. Pressure, the invisible shield. The most dangerous threat was low pressure. At 39 kilometers, pressure is almost zero. Without pressure, lungs cannot work, blood loses stability, the body fails. The suit created artificial pressure around the body. Not too high, not too low, perfect balance. Too much pressure would restrict movement, too little would mean death. Oxygen, every breath matters. The suit carried its own oxygen supply, but oxygen alone is not enough. The amount must be controlled. Too much oxygen can damage the body. Too little leads to unconsciousness. Sensors inside the suit adjusted oxygen flow constantly. Every breath was measured. Temperature control in a changing world. Near space is extremely cold. But as the man falls, temperature changes fast. Cold at the top, heat builds below. The suit had layers. Each layer had a purpose. Some reflected heat, some trapped warmth, some protected against friction. The suit adjusted automatically. The human inside never felt extreme temperatures. If the system failed, hypothermia or overheating would occur quickly. Movement without freedom. The suit was strong, but strength reduces flexibility. Every movement required effort. Simple actions felt heavy. This was dangerous because body position during the fall was critical. The suit had to allow controlled arm movement, leg adjustment, stability at high speed. Too stiff and control is lost. Too flexible and protection is lost. Balance was everything. The helmet, a window to survival. The helmet was more than protection. It was a control center. Inside the helmet, communication systems, oxygen flow controls, anti-fog systems. The visor had to stay clear. Fog would block vision. Blocked vision could cause panic. The helmet also protected against wind force at supersonic speed. Air hitting the helmet at that speed could snap the neck. The design prevented this. Communication with Earth, even at the edge of space. The man was not completely alone. A communication system connected him to Earth. Mission control could hear his breathing. He could hear their voices. This connection was psychological survival, but communication was limited, delays, signal weakness. Once the jump began, communication could fail at any moment. That is why he trained to continue without guidance. Backup systems for every failure. Space missions planned for failure. This jump was no different. If one system failed, another took over. Backup oxygen, backup pressure valves, backup power. Even the parachute had backups. Main parachute, reserve parachute, because in near space there are no second chances. Testing the impossible on Earth. Before this mission, the suit was tested brutally. Pressure chambers simulated near space. Wind tunnels simulated extreme speed. The suit was frozen, heated, twisted. Engineers tried to break it, because near space would show no mercy. Only after surviving countless tests was the suit approved. The weight of trust. When the man wore the suit, he trusted it with his life. Trust is not blind, it is built through training. He trained wearing the suit for hours, learned its limits, learned its resistance. By the time of the jump, the suit felt familiar, almost like a second skin. The final check inside the capsule. Moments before the jump, final checks began. Pressure stable, oxygen stable, temperature stable. Mission control confirmed each system. No alarms, no warning. This was the best possible moment, but perfection does not guarantee safety. Technology vs nature. Nature does not care about technology. Gravity pulls, air resists, physics dominates. Technology only gives a chance to survive, a chance to learn, a chance to push boundaries. The moment the suit became everything. When the man stepped out of the capsule. The capsule no longer mattered. The balloon no longer mattered. Only the suit mattered. Between his body and death there was nothing else. This was the true test, not of courage, but of engineering. A human wrapped in science. As he fell through the edge of space, the suit held. Pressure remained stable. Oxygen flowed. Temperature adjusted. Every system worked together. Science and human courage became one. But the mission was not over. Survival in near space was only one phase. Below waited thicker air, stronger forces, new dangers. The suit would soon face its hardest challenge. The violent atmosphere of Earth. As the man continues to fall, something extraordinary is about to happen. Something no human body was ever designed to experience. He is about to move faster than sound. Speed builds in silence. In the first moments after the jump, the fall felt calm, almost peaceful. But now, the silence begins to change. The air around him slowly becomes thicker. Still thin, but enough to react. Gravity has been pulling him non-stop. Second by second, his speed increases. There is no engine, no fuel, no thrust, only gravity, the most honest force in the universe. Understanding the sound barrier on Earth, the speed of sound is about 1,234 kilometers per hour. When an aircraft reaches this speed, something dramatic happens. Air can no longer move away fast enough. Pressure builds up. Shock waves form. This creates a sonic boom. For decades, breaking the sound barrier was considered impossible. Then jets did it, but a human body, that was never supposed to happen. Why this is so dangerous? Aircraft are built for this. They are shaped to cut through air. They are strong. They are controlled by computers. The human body is none of these things. Arms, legs, head, all exposed. At supersonic speed, even air becomes solid-like. It can tear materials apart. The question scientists feared most was simple: what happens when a human reaches Mach 1? The body as a bullet. As speed increases, the man's body becomes a projectile. Air molecules slam into the suit. Each impact is tiny, but millions happen every second. This creates pressure. Uneven pressure can cause sudden spinning, violent shaking, loss of control. This is why stability is everything. The man must stay perfectly aligned. Mission control watches history approach on the ground. Screens show numbers climbing fast. Speed rising, altitude dropping, heart rate elevated but controlled. Scientists realize what is coming. They whisper it quietly. He's approaching Mach 1. No one celebrates. This is the most dangerous moment of the mission. No sonic boom at supersonic speed. People expect an explosion. A loud boom, but nothing like that happens. Why? Because sound needs air. And at this altitude, air is still too thin. The man breaks the sound barrier in complete silence. No noise, no shock wave felt. Only numbers on a screen confirm the impossible. A human faster than sound. For a brief moment, the man becomes something no human has ever been. A human moving faster than sound. No plane, no rocket, no machine. Just a body wrapped in a suit. This moment lasts only seconds, but it changes history. What the body feels inside the suit, the man feels intense pressure. Not pain, pressure. The suit tightens slightly as systems adjust. Breathing becomes heavier. The wind begins to scream around him. This is no longer silent falling. This is violent movement, yet the body remains stable for now. The threat of spin returns at supersonic speed. Even a small mistake can be fatal. A slight tilt of the shoulder, a small leg movement. Air pressure becomes uneven. The body begins to rotate, slow at first. Mission control notices it instantly. Rotation rate increases slightly. This is dangerous territory. The flat spin nightmare. Scientists fear one thing more than anything else: the flat spin. In a flat spin, the body rotates horizontally, blood rushes away from the brain, vision turns black, unconsciousness can happen in seconds. If unconscious, the man cannot correct his position, and gravity will not stop. Training takes over inside the helmet, fear does not scream, training speaks calmly. The man remembers his drills, small movements only, he adjusts his arms, aligns his body, reduces surface imbalance. These movements feel slow, but at this speed they are powerful. The spin slows, seconds feel like minutes, data streams change. Rotation rate decreases, stability returns, mission control exhales. The worst moment has passed, but the danger is not over. Supersonic air becomes a weapon as air density increases, speed begins to drop. But now air resistance is stronger. The suit takes a beating. Wind hits like an invisible wall. The helmet absorbs massive force. Neck muscles work hard to keep the head stable. Any sudden movement could injure the spine. The suit does its job. Heat begins to rise, breaking the sound barrier creates heat, not like fire, but friction. As air molecules compress and slide across the suit, temperature rises. The suit's thermal system activates. Heat is spread across layers, released slowly. The man never feels burning, but sensors show rising numbers. Everything is working at its limit. The most extreme freefall in history at this point, the fall becomes legendary. No human has ever experienced this combination of altitude, speed, pressure change. This is not skydiving. This is controlled survival. The sound barrier is behind him eventually. Speed drops below Mach 1. The most dangerous milestone is passed, but celebration is impossible. Below waits dense atmosphere, thick air, violent forces. The next phase will test endurance even more. A human data point at this moment, the man is no longer just a person. He is a living experiment, every heartbeat recorded, every movement analyzed. His body teaches scientists what no machine could. This data will protect future astronauts. Why this moment matters: breaking the sound barrier proves something critical. The human body with the right protection can survive extreme physics. This changes emergency planning for space missions. It changes suit design. It changes how far humans can push. Gravity never stops even after breaking records. Gravity continues its work. The fall is far from over. Below, the air grows thicker. Faster deceleration awaits. The most physically demanding phase is coming. No applause yet on Earth, no one claps. Not yet, because survival is not confirmed. The mission is only half complete. A new challenge ahead. The man now faces powerful air resistance. Rapid deceleration, parachute timing. One wrong second could be deadly. The universe has tested speed. Now it will test control after breaking the sound barrier. Many people think the danger is over. They are wrong. In reality, the most dangerous moment comes after speed. When control is tested, the atmosphere strikes back. As the man falls deeper, the atmosphere grows thicker. At first, air resistance helps slow him down. Now it becomes violent. Wind pushes hard against the suit. Forces hit from every direction. This is no longer silent falling. This is a battle. The body feels heavy. Movement becomes difficult. Gravity still pulls downward, but air now fights back. The sudden change in forces near space was calm. Here, the atmosphere is chaotic. Air density changes fast. 1 second feels smooth, the next feels unstable. These sudden changes are dangerous because the human body reacts slower than physics, and physics does not wait. The warning signs: mission control notices something troubling. Rotation rate begins to increase again, not fast, but steady. Small rotations are normal, but steady increase means loss of balance. This is how accidents begin. The human body under stress inside the suit, the man feels it. Not fear, pressure. His chest feels tight. Breathing becomes heavier. Blood pushes against the body. The heart works harder. This is the effect of high G-forces. Too much force can reduce blood flow to the brain, cause vision loss, lead to blackout. This is called GLOC, and it is deadly in freefall. When vision starts to fade for a moment, the edges of vision darken. Colors lose sharpness. This is the brain warning the body. Oxygen is still flowing. Pressure is stable, but force is increasing. The man must act fast. The flat spin begins, then it happens. The body tilts, not much, but enough. Air pressure becomes uneven. The man begins to spin, slowly at first, then faster. This is the nightmare scientists feared, the flat spin. Why flat spin is so deadly: in a flat spin, the body rotates horizontally. Arms and legs spread outward. Centrifugal force pulls blood away from the brain. Even with oxygen, the brain starves. Unconsciousness can occur in seconds. Once unconscious, there is no recovery. Gravity will finish the job. Mission control goes silent on Earth. The control room freezes. Data confirms the spin. Rotation rate increases. Heart rate spikes. No one speaks. There is nothing they can do. No button to press. No command to send. This moment belongs to the man alone. Training vs instinct. Instinct says panic. Training says stay calm. Panic causes wild movement. Wild movement increases spin. The man forces himself to slow down. He remembers the drills. Small corrections, very small. Fighting the spin, he pulls his arms closer to his body. Not suddenly, slowly, he adjusts leg position, reduces surface area. This is physics: reduce imbalance, reduce rotation. But time is short. The edge of consciousness vision narrows. The world becomes dim. This is the last warning. If consciousness is lost now, recovery is impossible. The man focuses on breathing, slow, deep. He must stay awake. The spin peaks for a few terrifying seconds. The spin reaches its highest rate. The body feels weightless and heavy at the same time. The suit creaks under stress. Sensors flash warnings. Mission control prepares for the worst. Then something changes. The rotation slows, just slightly. Then more. Data begins to improve. Heart rate stabilizes. Blood flow returns to the brain. Vision clears. The man remains conscious. Control is regained. The flat spin is broken. The body returns to vertical alignment. Stability returns. This moment decides everything. The deadliest danger has passed. Why this moment matters more than speed breaking the sound barrier was history. Surviving the flat spin is survival. This proves something crucial. Humans can recover from extreme instability in near-Earth conditions. This knowledge will save lives. The cost of the battle: the man is exhausted. Muscles ache. Breathing is heavy. The suit did its job, but the human body paid the price. Adrenaline kept him alive. Now it fades. No time to rest. There is no rest in freefall. Below, dense atmosphere awaits. Parachute deployment is approaching. Timing will be critical. Too early and the parachute could tear apart. Too late, and there may be no recovery. Mission control speaks again after long silence. Voices return. Calm, controlled, they confirm stability. Altitude is dropping fast. Everything now depends on precision. The weight of survival: the man understands something deeply. This jump was not just about technology or science. It was about human limits, about calm under pressure, about trust in training. Gravity shows no mercy. Even after escaping death, gravity does not stop. Earth grows larger. Clouds become clear. The fall enters its final phase. The atmosphere now dominates. Preparing for the next critical moment, hands move toward parachute controls. Muscles stiffen, mind sharpens again. One more major challenge remains: deployment. A thin line between life and death. This mission has balanced on thin lines before. This moment is no different. A few seconds, a few meters, a few decisions. The universe is still watching above him. Space fades. Below him, Earth waits. Between them, a human fights physics, not to win but to survive. The fall continues. The deadliest moment has passed, but the mission is not complete. The final test is coming. The most dangerous spin is over. The man is alive, but survival has not been confirmed yet because gravity never stops. The Earth comes closer as the man continues to fall. The Earth grows larger. Clouds are no longer soft shapes. They are thick walls of white. The blue curve of Earth slowly disappears. Now this feels real. This is no longer space science. This is human survival. From silence to roar, near space was quiet. Now the air is loud. Wind screams around the suit. The pressure on the body increases with every second. The fall that once felt slow now feels violent. The body shakes slightly, not from fear, from force. The atmosphere takes control at lower altitude. Gravity is no longer alone. Air resistance becomes powerful. It pushes hard against the suit. Speed drops quickly. The man feels his body being pulled in different directions. This is deceleration. It is not gentle. Why deceleration is dangerous: many people think slowing down is safe, but sudden slowing can be deadly. The body wants to keep moving. Organs shift inside. Blood surges forward. This creates strong G-forces. If too strong, vision can fade. Breathing becomes difficult. The brain can lose oxygen. The man must stay perfectly aligned. The suit takes another test. The suit tightens slightly. Pressure systems adjust automatically. The goal is simple: protect the body while speed drops rapidly. Sensors monitor everything: heart rate, oxygen levels, internal pressure. Any failure now would be fatal. Mission control watches the clock on Earth. Mission control tracks altitude carefully. There is one critical number: parachute deployment height. Too early, air is still too thin. Parachute may not open. Lines could snap. Too late, not enough time to slow down. Impact would be deadly. Timing is everything. Waiting is the hardest part. The man knows the parachute is there, but he cannot pull it yet. This waiting is dangerous because fear grows in silence. Every second feels long. Every sound inside the helmet feels louder. But training says one thing: wait. Trusting numbers over instinct. Instinct says slow down now. Training says wait for the right altitude. The man looks at his instruments. Numbers are clear. Still too high, still too fast. He keeps falling. The human body under extreme stress, muscles are tense. The neck works hard to keep the head stable. The suit absorbs most of the force, but not all of it. The body feels heavy. Breathing requires effort. The man focuses. Slow breathing, controlled movement. Stay calm. Clouds rush past. Suddenly, clouds surround him. Visibility drops. White fills the visor. This is disorienting. There is no clear sense of direction. Up feels like down. This is dangerous. The man keeps his body aligned using training alone. Breaking through the clouds. Seconds later, the clouds thin. The ground becomes visible far below: fields, mountains, Earth. This sight changes everything. Now the destination is clear. The final countdown begins. Mission Control speaks calmly. Altitude is approaching the safe zone. Wind conditions look acceptable. All systems are ready. The moment is close. Why parachutes can kill? Parachutes look simple, but at high speed they are dangerous. If deployed too fast, sudden force can break the necklines, can tear the canopy, can collapse. That is why a stabilizing drogue chute is used first. It slows the body gently. Then the main parachute follows. Hands move into position. The man moves his hands slowly. Not rushed, not shaking. Every movement is deliberate. He confirms altitude again. This is the last major decision of the mission. The drogue parachute deploys. He pulls. For a fraction of a second, nothing happens. Then a strong pull. The drogue chute opens. The body jerks backward, hard but controlled. The fall changes instantly. Violent forces hit. The deceleration is intense. The body is pulled upward. Blood shifts. Vision narrows slightly, but the suit holds. The drogue chute stabilizes the fall. Spin is reduced. Control returns fully. A moment of relief. For the first time since the jump, there is relief, not celebration, relief. The man knows this is working, but the mission is not over. The main parachute still waits, preparing for the final opening. Speed drops further. Air resistance increases. This is now traditional skydiving territory, but the body is exhausted. Muscles are tired. Focus must remain sharp. The main parachute altitude reaches the final mark. The man pulls again. This time the main parachute opens. The force is strong but manageable. The canopy spreads wide above him. The fall slows dramatically. Silence returns. The roar of wind fades. Now there is only gentle movement. The earth feels calm again. The most dangerous freefall in human history is over. Mission Control confirms success on Earth. The control room erupts quietly. Not cheers, but relief. Data confirms stable descent, normal heart rate, safe speed. The mission has succeeded. A human returns from the edge. As the man drifts downward, the reality sets in. He survived, not just the jump, but physics, near space, supersonic speed, loss of control, all of it. The final descent. The ground approaches slowly. Wind carries him gently. This is the safest part of the journey, but focus remains. Landing mistakes can still cause injury. Touching Earth again, feet touch the ground. The body absorbs the impact. Knees bend, balance holds. He is standing, alive. The world catches up seconds later. Support teams arrive. Voices fill the air, hands reach out. The suit is open, fresh air enters. This air feels different. He breathes deeply. The meaning of the moment. This is not victory. This is understanding. Understanding what humans can survive. Understanding what science can achieve. Understanding how small mistakes matter. A mission completed, a story not finished. The jump is over, but its impact is just beginning. The data collected will travel far, into labs, into future missions, into space history. One final look up before leaving the landing site. The man looks up. The sky looks normal again, blue, peaceful, but he knows what exists above it. The silence, the danger, the edge of space. The journey ends. The legacy begins. He returned from a place humans were never meant to be. Not as a hero, but as proof that with preparation, technology, and courage, humans can touch the edge of the universe and come back. The jump is over. The man is safe on Earth, but the story is far from finished, because some moments do not end when the action stops. Some moments change the future, and this was one of them. Silence after history. After landing, the world slowly returns to normal. The wind moves gently. The sky looks ordinary, but nothing is the same anymore, because for the first time in history, a human has fallen from the edge of space and survived, not by luck, but by science. More than a world record. Many people remember this mission as a world record. The highest jump, the fastest freefall, but records fade with time. What truly matters is what was learned. This jump was not done for applause. It was done to answer questions that no computer could. The data that changed everything during the fall. Thousands of sensors collected data. Every second mattered. Scientists recorded heart rate under extreme stress, blood oxygen levels at near space altitude, body stability at supersonic speed, effects of rapid deceleration. This data was priceless, because it came from a real human body. Not a dummy, not a simulation, a living person. Understanding human limits. Before this mission, scientists only guessed. They guessed how much speed the human body could handle. They guessed how much pressure change was survivable. Now they knew. They learned the human body can remain conscious at supersonic speed. Flat spin can be survived with correct training. Pressure suits can protect humans in near-space freefall. These answers changed everything. Saving future astronaut space missions are dangerous. Launch failures happen fast. Sometimes astronauts may need to escape at extreme altitude. Before this jump, survival chances were unknown. Now they are understood. This mission helped engineers design better escape systems, improve spacesuits, plan emergency procedures. Lives will be saved in the future because of this knowledge. A new era of space suits. The suit used in this jump became a blueprint. Engineers studied every detail. They improved pressure systems, joint flexibility, thermal control, helmet stability. Modern spacesuits now carry lessons from this fall. not from orbit, but from the edge of space. Near space is no longer a mystery. For a long time, near space was ignored. Too high for planes, too low for spacecraft. This mission changed that. Scientists now see near space as a test zone, a research environment, a possible future travel region. Space tourism, high-altitude research, and emergency systems all benefit from this understanding. The psychological side of survival. This mission also revealed something important about the human mind. Technology alone was not enough. Calm decision-making saved this life. Training overpowered panic. Focus defeated fear. This showed that future astronauts need not only physical strength, but mental discipline. One human. One giant lesson. This was not about one man being brave. It was about humans learning together. Engineers, doctors, scientists, pilots, everyone played a role. This jump showed what humanity can achieve when knowledge and courage work together. From near space to deep space, the lessons learned here do not stop at Earth. They travel outward, to the moon, to Mars, to deep space. Future missions will face emergency evacuations, equipment failure, unexpected conditions. This jump provides a foundation, a real example of survival against physics. Inspiration beyond science. Millions of people watched this mission. Not all of them were scientists. Some were students. Some were dreamers. Some were future explorers. This jump showed them something powerful, that limits exist only until they are tested. Why this was not a stunt. Some people called it a stunt. They were wrong. A stunt is done for attention. This was done for understanding. Every risk was calculated. Every step had purpose. The goal was never danger. The goal was knowledge. A reminder of human fragility. This mission also reminded the world of something important. Humans are fragile. Without protection, survival would be impossible. Space is not friendly. It does not care about courage. Only preparation matters. This respect for nature is critical for future exploration. The thin blue line from the edge of space. Earth looks small, wrapped in a thin blue layer. That layer protects all life. This jump reminded humanity how precious that layer is, how fragile our home truly is. Space exploration teaches us about the universe, but it also teaches us about Earth. A legacy written in air. This jump left no footprints, no flags, no permanent mark in space. Yet its impact is permanent. It lives in data, in designs, in future missions, and in human confidence. The universe did not change. The universe remained silent. Gravity still pulls, physics still rules, but humanity changed. Because now humans know they can survive closer to space than ever before. What comes next? This mission opened doors, higher jumps, better suits, safer missions. The edge of space is no longer unreachable. It is studied, understood, respected. The final meaning. This story is not about falling. It is about preparation. It is not about speed. It is about control. It is not about fear. It is about understanding fear. One last thought. A human once stood at the edge of space and stepped forward, not to escape Earth, but to learn how to protect life beyond it. The journey ends. The jump is complete. The data is collected. The lesson is learned. But the journey of space exploration continues. Always forward, always upward, always into the unknown, and it will decide the ending of this story. The most dangerous part was yet to come.